Hello everyone, welcome to Be a Cloud Pro. আজকের আলোচনার বিষয় গেটিং স্টার্টেড উইথ কুবারনেটিস। আজ আমাদের সঙ্গে জার্মানি থেকে আছেন আরিফুল হক খান। তিনি অ্যাডেসো অ্যাজ এ সার্ভিস GmbH জার্মানিতে সিনিয়র ক্লাউড ইঞ্জিনিয়ার পদে কর্মরত। তিনি একই সঙ্গে বিএসসি ইন ইঞ্জিনিয়ারিং ফ্রম রাশিয়া ইউনিভার্সিটি অফ ইঞ্জিনিয়ারিং অ্যান্ড টেকনোলজি, সার্টিফাইড কুবারনেটিস অ্যাডমিনিস্ট্রেটর এবং AWS সার্টিফাইড ডেভঅপস ইঞ্জিনিয়ার অ্যান্ড সলিউশন আর্কিটেক্ট। আজকের ওয়েবিনারে আমরা কুবারনেটিস সম্পর্কে বিস্তারিত আলোচনা করব এবং পরিশেষে থাকবে কোশ্চেন আনসার সেশন। অনুষ্ঠানের শুরুতে আমি লিসেনারদের বলবো ওয়েবিনার সম্পর্কে তাদের গুরুত্বপূর্ণ মতামত bacloudpro@gmail.com এ ইমেল করে জানাতে পারেন। টেকনোলজি রিলেটেড গুরুত্বপূর্ণ ভিডিও আমরা আমাদের ইউটিউব চ্যানেলে নিয়মিত আপলোড করি। এছাড়া পূর্ববর্তী ও পরবর্তী ওয়েবিনারের ভিডিওগুলো দেখতে চাইলে আমাদের ইউটিউব চ্যানেলে সাবস্ক্রাইব করুন। এছাড়া সোশ্যাল মিডিয়াতে আমাদের কমিউনিটিতে যোগদান করে আপনাদের মতামত জানাতে পারেন। স্ক্রিনে আমি আমাদের সোশ্যাল মিডিয়ার লিঙ্ক এবং ইমেল অ্যাড্রেস শেয়ার করব। আপনারা ওখান থেকে ক্লিক করে সরাসরি আমাদের ইউটিউব চ্যানেল বা সোশ্যাল মিডিয়াতে চলে যেতে পারেন। লিসেনারদের অনুরোধ করব প্রেজেন্টেশনের সময় তাদের কোনো প্রশ্ন থাকলে ইফ ইউ হ্যাভ এনি কোয়েশ্চেন জাস্ট লেট আস নো ইন চ্যাট বক্স। শুরুতে আরিফুল ভাইকে অনুরোধ করব তার প্রেজেন্টেশনটা শেয়ার করার জন্য।
Okay. Yeah, can you see it?
Yeah.
Move this one. So should we start?
Yeah, please
Okay.
start.
ধন্যবাদ সবাইকে আজকের সেশনে যোগদানের জন্য। আমরা আজকে কুবারনেটিস বেসিক্স এবং কিভাবে একটা কুবারনেটিস ক্লাস্টার লোকাল মেশিনে ক্রিয়েট করে সেখানে কুবারনেটিস এক্সপ্লোর করা যায় কিংবা প্লেগ্রাউন্ড হিসাবে সেখানে প্লে করা যায় সেটা শিখবো। At the beginning, little bit about myself. Okay. Yeah, my name is Ariful Khan. I'm working as a senior cloud engineer at Adesso as a service GmbH. I have 8 to 9 years of working experience. I started working as a software engineer in Bangladesh in 2012 and then moved to Malaysia, now working in Germany. And I'm Kubernetes certified for 1.5 years almost now. I'm certified as a application developer as well as administrator. So let's start. We'll look into what is Kubernetes first, then we'll explore bit by bit. So Kubernetes is a very big topic. You have a lot to learn, and in our today's session, we'll only learn about the basic building blocks and how to start the cluster. So our goal is to show how you can create a local Kubernetes cluster and teach you enough so that you can start playing into your local Kubernetes cluster to learn more. So that's our goal today. Yeah. So what we'll learn, we already discussed a little bit, but this is topic-wise list. So we'll look into Kubernetes architecture, how Kubernetes, in short, how Kubernetes work or like a function. Then we'll learn about pod, replica set, deployment, and service. Those are most basic building block. Almost every project in Kubernetes, we will use all four of it. And then we'll learn how to learn and show how to create a playground cluster using Kubernetes in Docker. It is called kind. Then we'll have a demo with kind, and we'll also look into briefly what is ingress controller is, as well as uh, Helm, that's a packet manager for Kubernetes. We will also look into that. So let's start. Uh, so what is Kubernetes? Uh, in short, Kubernetes is a container orchestration platform where we can run our container at a scale. So this is an open source project, community driven project. Originally, this is developed by Google. They have their own container runtime platform. They modified it and released it as a Kubernetes in 2014, I guess 2015, and it helps you managing your containerized application. And you can run Kubernetes in any place: physical machine, virtual machine, cloud. Even some people are running Kubernetes into Raspberry Pi, and it's help you to run thousands of container in a single cluster. I guess the tested number is 30,000 plus. This is the official definition of Kubernetes. I don't want to, we are not going to read it line by line, but a few most important thing here is it is portable, extensible, it's declarative, so you don't need to uh, say how to run your application. You will just define the state, and Kubernetes will make sure that it is running at a correct state. And also automation is very, very easy with Kubernetes. Yeah, so that's Kubernetes. But before looking into Kubernetes, we also need to understand a little bit about container and other uh, platform that we are running our infrastructure, physical machine or virtual machine. To understand Kubernetes a little bit better, you at least have to have a basic idea about container. To be specific, most of the people are using Docker because that is the most popular one. So if you have a basic understanding how Docker work or how to run a Docker container, that will be really, really helpful to understand Kubernetes related topics. So we can see here three different type of infrastructure. First is traditional, second is virtualized, and last one is uh, containerized infrastructure. First one, we can see that we have hardware and operating system. In top of that, we are running three applications. The problem with that is, let's say we are running Python application, and one application is using Python 2.7, one is using Python 3.6. So managing those dependencies will become more harder and harder, and more application you run, it will face more challenges there to run it, managing all the dependency and also making sure that every application is up and running properly. So to solve this problem, we start to use virtualized machine. Those separate out our physical host into some smaller machine, but the problem is we can see that we have two operating system. Actually here we can see three, so that will be a host operating system, and for each and every virtual machine we will also have a guest operating system. So it uses up a lot of resource, although it can isolate all the application very, very easily, but automation is more difficult here. And the third thing, we come into container. Although container is around for very, very long time, but it came into mainstream after release of Docker in 2014. And we can see that we don't have this duplicate operating system anymore. So we are running single operating system. In top of that, we are running a container runtime, and then we are running multiple container. So Kubernetes came into picture when you are like running your application at a big scale. So we can see that we can see here one physical machine and or virtual machine it can be virtual machine, and we are running single operating system and running three containers there. But let's think about a use case where we are running 100 machine, physical machine or virtual machine, and we are running 1000 container. Only with Docker or even with Docker Swarm, it's very difficult to manage there. And Kubernetes is trying to solve that. It already solved a lot of problem, and it is one of the best platform right now to run container at a large scale, large enough scale. So let's go to the next one. So we'll start with Kubernetes architecture. We'll just divide it into main component and we'll look into it what is the main function of this component. So a Kubernetes cluster we can divide into two parts. First will be control plane, and second is number of no, it's not node, it's nodes, because normally there is multiple node, but they are similar. So we can just say that it is control plane and node. So in control plane, we will have multiple component inside this control plane. Also, it's called master node. We can see two here. First is API server, and second is etcd. So API server is like a brain of Kubernetes cluster. So all the communication from other component is come to API server, and API server decided what to do. And etcd work as a memory of the Kubernetes cluster. So whatever API server is doing, it have to remember what it have done so that it can do it continuously, and all those state is saved into etcd. And then come the component of node. First component is kubelet, that is a agent running into Kubernetes node. It maintain communication with the API server, and it just continuously query the API server what to do. And it also makes sure that if that particular node have to run, let's say 5 container, this 5 container is up and running, and it can communicate with other. And the last component is kubeproxy, that is a flat network created by Kubernetes around the whole cluster, so that all the container can communicate with each other to specific all the so that all the pod can communicate with each other. We will look into what is a pod in few minutes, but let's say for now pod and container is same. When I'm saying container, actually I mean pod. So that's it, and we have multiple other node. And this is a details architecture of Kubernetes provided by Cloud Native Foundation. The link is provided at the end, at the button. You can just go if you are interested more. So the next thing. So today we'll discuss some Kubernetes building block that will be very helpful if you want to continue your learning on about Kubernetes. Uh, those are the pod, replica set, deployment, and service. So what is a pod? That doesn't make any sense. What is a pod? So this word doesn't specify anything, or like it's not self-descriptive of word, but to just put it into a simple sentence, a pod is a wrapper around container. that is used by Kubernetes, and the pod is the smallest unit in Kubernetes. So you can compare it with atom in chemistry. So pod is like atom into Kubernetes world. So the yeah, first thing is Kubernetes cannot run container directly. There's a reason for that because Kubernetes is not running a single uh, container runtime. You can run Docker container in Kubernetes. You can run Rocket or any other container platform. So it needs to be agnostic about the container. So it's not running the container directly. It is using a wrapper on top of container that is called pod. And that is the smallest unit in Kubernetes. And second thing is pod work as a local host inside for all the containers. So if we have a pod and if we are running, let's say 2 container inside that, uh, the communication between 2 pod and all the resource that look like you are running that's in a local host. So let's say if we have 2 container, one is Nginx container, one is MySQL. So the Nginx can directly communicate with the MySQL container at local host 556 5306. I forgot the port number, sorry for that. But it can directly communicate on that port using localhost. It doesn't need to know any other special IP or anything. And then this is the smallest unit. And one most important thing about pod is you should not run multiple uh, main container in a pod. So what does I mean by that? So let's say we have a backend application that is that database and also have this backend application running into, let's say, Python. So we should run Python in a single pod and we should run MySQL in another pod. We should not put these 2 container in single pod because we need to scale both of these applications separately. If we put into same place, that will be a problem. Also, database is like a single thing. You don't want to run like 10 database instance and everybody have to communicate with the same database. That's why we should put the MySQL in a separate pod and all the Python will communicate with that pod. They don't want to, they should not communicate in local host. And one good thing about pod, they have their own IP, so we can directly communicate with one pod. And on recreation, it also get a new pod, so the new IP address. So the IP address of a pod is not persistent; it is ephemeral. So yeah, so that's about pod, but the understanding about pod is very important. So if anybody have any question around pod, maybe we can discuss about that, or we should discuss that right now. Yeah, if anybody have any question, please write into chat. Saravai will help us to discuss about those questions. No question? Okay. Saravai, do you have any question? Okay. Okay, let's move to the next one. So we want to compare between a pod and container. So what is the difference between a pod and container? I guess most of us already familiar with container at a varying degree. Maybe we are using in production or local machine or any other way. But I guess very few of us are familiar with pod. So let's see what is the difference between a container creation and pod creation workflow. So we can see we have a Okay, let's get the pen. We have a Docker file here, and we are using a Node.js application that we define the Docker file for this Node.js application. And from this Docker file, we can create a Docker image, and we can just put it into a Docker repository, maybe Docker Hub or any private repository like AWS ECR. Then using that Docker image, we can
Sorry,
build,
Ariful,
yeah,
I wasn't able to actually unmute myself. There was some restriction, and there's some question. I should
yeah, sure.
forward it to you. Uh, it's a there's a question. Can you please explain why different pods?
Yeah, why different parts? So why should we use like a multiple part? Why should we divide the application into multiple parts? So one good use case is scaling the application. So and also different application need a different kind of attention on those. Let's say if we compare a tier application that is like very common, one front end, one backend, and also database. So database application that need special care because those are stateful application, and we want to like have a single entry point on that so that all the backend application can communicate with database server. But maybe will not run like uh, 10, 20 instance of that database server, or let's say we will not run 20 container of this database server, considering that every pod have only one container.
Okay.
Let's say we are running only three. And then we have this backend application. Maybe it has also do not are not doing a lot of things. So maybe it running at medium load. So we are running 10 uh, pod for database, sorry, backend application. And front end have a lot of load on that and lot of traffic. So let's say we are running 20 front end application. So we can see that if we separate out the application by pod, we can independently skill that. That's one of the good reason
So
we should
it
separate
means
out things
that
in pod.
because in an application there's a different separate part. For example, front end databases, also some backend tasks. We all can just scale separately by using different ports. For example, for front end we can use 20 30 ports, and for databases we can use 10 20 ports. For backend tasks we can use 10 ports, and if we need to scale we can increase it separately. Am I
Yeah,
correct?
independently.
Yeah,
So
yeah.
that is one reason. And also like if we separate out in multiple part, it will be easier for us to maintain. So one thing is we don't need to scale up and down everything together. We can independently scale things. And also like if there is a issue with front-end application, we can independently deploy front-end application only. We don't need to
Ah,
deploy like back-end application.
yeah, yeah.
So that is one of the reason we should not put. It's not that if we put everything together, it will not work. It will work, but we should never do that.
Mhm.
That is like a very bad practice.
Uh, uh, mm, I'm just explaining Bengali. Someone just requested if you can, Ariful, you can, or I can just translate it to Bengali on
Okay,
my
let me
best
try.
understanding.
Let me
Someone
try.
just requested to explain the pod in Bengali.
Okay, pod in Bengali. So everything or just this scaling issue?
Uh, just scaling, why different pod? Explain the pod things, why you are using different pod, or what is pod? Just briefly.
Okay. Okay, let me try to explain it in Bengali. So uh, Kubernetes শুধু Docker container রান করে না, Kubernetes অন্য container runtime রান করে, যেমন Rocket or other one. So for Kubernetes এর জন্য যেটা important সেটা হচ্ছে যে একটা unified approach to run container. So uh, অলসো কুবারনেটিস যেটা ট্রাই করে সেটা হচ্ছে যে আইসোলেটেড একটা ইউনিট তৈরি করে যেটা ইন্ডিপেন্ডেন্ট হবে। আমি ডকার কন্টেনার রান করি আর রকেট কন্টেনার রান করি, সেটা ইন্ডিপেন্ডেন্ট হবে। সেটা একটা কারণ। আরেকটা কারণ হচ্ছে যে কুবারনেটিস যেটা করে সেটা হচ্ছে যে যতগুলো আই ডোন্ট নো, আমার ইচ্ছে ছিল না বা লিনাক্স নেম স্পেস সম্পর্কে ডিসকাস করা, কারণ এটা বিগিনার লেভেল
না
সেশন।
সমস্যা নাই, ওটা
কিন্তু
করতে
যেটা
পারেন।
করে সেটা হচ্ছে যে প্রত্যেকটা পড যেটা করে সেটা হচ্ছে যে একটা সেপারেট নেম স্পেস, নেটওয়ার্কিং নেম স্পেস, প্রসেসিং নেম স্পেস, লাইক সিপিইউ শেয়ারিং, সবকিছুর জন্য আলাদা আলাদা একটা নেম স্পেস তৈরি করে এবং একটা পডের ভিতর সবগুলো নেম স্পেস থাকে। সো এই নেম স্পেস গুলো ইজিলি ম্যানেজ করার জন্য পডটা ইন্ট্রোডিউস করা হয়েছে। এবং যে কয়টা কন্টেনার আমরা একটা পডে রান করছি সেগুলো একটা কন্টেনার ভিতরে একটা পডের ভিতর রাখা হচ্ছে। এবং যেহেতু সেম নেম নেটওয়ার্ক নেম স্পেস সেগুলো রান করছে, সো it's act like a local host for all the containers. So যদি আমরা চিন্তা করি এভাবে যে আমরা যখন আমাদের লোকাল হোস্টে রান করছি কন্টেনার 10টা কন্টেনার, সো 10টা কন্টেনারে একটা আরেকটার সাথে লোকাল হোস্টের মাধ্যমে কমিউনিকেট করতে পারছে। কিন্তু কুবারনেটিসে আমরা সেটা চাই না, আমরা চাই যে প্রত্যেকটা পড আইসোলেটেড থাকবে। সো এটা শুধু আইসোলেশনের জন্য না, ইফ আমরা যখন ভার্চুয়াল মেশিন দেখছিলাম, ভার্চুয়াল মেশিন একটা হাই লেভেলের আইসোলেশন প্রোভাইড করে। কন্টেনার, ইফ উই আর রানিং কন্টেনার, আমরা সেটা পাচ্ছি না। কিন্তু যখন আমরা পড রান করছি আমরা অলমোস্ট সেম লেভেলের isolation পাচ্ছি। So you can imagine pod is like a virtual machine. It's not a virtual machine, but like a virtual machine.
বাট আমরা কি এটা বলতে পারি যে পড হচ্ছে প্রসেসর ভার্চুয়ালাইজেশন অর সামথিং লাইক দ্যাট?
না, এটা শুধু প্রসেসর না, এটা ভার্চুয়ালাইজেশন, সেটা ঠিক। শুধু প্রসেসর না, প্রসেসরও ইনক্লুডেড, নেটওয়ার্কিং প্রসেসর, আইও ইন্টারাপশন, যত ধরনের নেম স্পেস আছে লিনাক্সে সেগুলো ভার্চুয়ালাইজ করছে, সেপারেট নেম স্পেস তৈরি করছে আপনার জন্য। এবার আপনি সেই নেম স্পেসটা ইউজ করছেন সবকিছুকে আইসোলেট রাখার জন্য।
I hope it's clear from the answer. If you
আমার
need
মনে হয়
further,
আগের চেয়ে কিছুটা ক্লিয়ার হয়েছে, কিন্তু আমি যেটা বললাম
জি জি
পডটা বোঝা সত্যি একটু ডিফিকাল্ট। এই জন্য না যে এটা অনেক ডিফিকাল্ট থিং, ইউ নিড এ সেপারেট মাইন্ডসেট, লাইক অল যেভাবে আমরা ইনফ্রাস্ট্রাকচার ইউজ করছি সেটার সাথে যদি কম্পেয়ার করি কুবারনেটিস অর পড, তো সত্যি একটু অন্যরকম। সো এটা বোঝার জন্য একটা ডিফারেন্ট মাইন্ডসেটের দরকার। যেটা আমি সাজেস্ট করব, ডকুমেন্টেশন আছে কুবারনেটিস, সেটা দেখেন, অন্য বই পড়েন এক্সেট্রা। It will take a little bit time. It's not that you will just read about it in single session and you will get it. You have to understand it, then you have to read about it. Also, you have to think about it. What something there's something called reflection that is used in learning community. So that's the important thing. So if you read something about pod, you just need to think about that in your free time, like when you are taking shower, then it will become more clear. But it will definitely get time, not because it is complex or something very difficult. It's very simple, but you need a different mindset to understand it clearly.
thanks, Arful. There's another question and also the answer is from Purna. Why different pod? Just there's another comment. For example, run Python in one pod and MySQL in another pod. If you both put both in the same pod, it will be difficult to scale. Different application need different requirement. For database, we want special care, so different pod better. If we separate based on pod, then we can independently scale. We can deploy the application independently, although we can put together different services together, but it is not a good practice. That's the comment I got. I just read out loud.
Yeah, that's thanks to Purna
Yeah, please
for
continue.
helping out us. Okay, so currently we are looking into the normal workflow for container. And we can see that there's three steps. One is getting the Docker file, then getting the Docker image, and at the end getting the Docker content. So when it came to Kubernetes, we'll get the Docker file, then we'll get the Docker image, but we'll not get the Docker container. Then we'll go to Kubernetes world. And what we have to do, we have to create a pod definition file. So yeah, pod definition file. So this is a simple YML. There's nothing special about this. And we can see it's just simple YML file. We are just defining some property, and when we'll hand it over to Kubernetes, Kubernetes will use this information and it will pull the Docker image for Nginx, and it will deploy that one, wrapping it around a pod. And if we go to there, so this is look like a pod. If we imagine that this is a pod, inside that we are running a Nginx container. Okay, so that's about pod. So we can create pod easily with this configuration, and that's all good. But the problem is if we get this pod and somehow it's got deleted, like the uh, Kubernetes node that is running this pod, if that goes down or because of some error or something, the pod is got deleted, it will be gone. So we want something better so that it monitor it automatically and keep running it for us. So to solve this problem, if one more thing on top of pod that is called replica set came into picture. So replica set is not, it's doesn't officially define as a wrapper around pod, but like for our explanation, we can imagine that it's another wrapper around pod definition, not pod definition, and it knows how to get pod. So we'll provide the pod creation template to a replica set, and we'll say that we'll need 4 pod of this definition, and it will just get everything for us. And if one pod got deleted, it will automatically recreate it for us. So we don't need to worry about that one pod is going down, and also it will like take care of where to run it and all the other stuff. Yeah, so that sounds very good that we have a thing that will taking care of pod, and will always maintain the number of pod that we want. But what about getting the replica set? So if the replica set got deleted here, then all the pod will be down. So we need another thing. So to make sure that if replica set got deleted, it should be recreated. And then, oh, sorry, I already discussed about those. There is some point. So if we're looking into the slide later, you can look into that later, but we already discussed all those things. So second thing, sorry, we'll look into it just after discussing deployment. So then came into picture deployment. So deployment know how to get the replica set, and it will help us getting that. So one of the big problem with replica set will be we have a application that have version 1. This is running into Kubernetes cluster, and we have a replica set, and it's running 4 pod. Now we added some more feature, and we have version 2, and we want to run version 2. So how we'll deploy version 2 and decommission version 1. So what we have to do, v1 is running here, so we have to get a new replica set, and then we have to roll out all the pod, and then have to manually decommission version 1. So that's look like a lot of work. With deployment, that will be also solved. So how we can see now. So with deployment, we'll define how to get the replica set. Inside replica set, we already define how to get the pod. So deployment is deployment already know everything, how to get pod, how to get replica set, and etc. So if we want to do the same deployment of version 2 with deployment, we just have to like update version 1 to version 2 of the Docker image, and all those swapping of the replica set and pod will be happen automatically. So we have a small animation here. Let's see how it will happen. So we have version 1, and we just updated the deployment, and now deployment is getting version 2. So it will first get 1 pod of version 2, and it will test with the health check. So every pod also have something called health check to make sure that the pod is working as it should be. Like if we are running MySQL, then MySQL is up and running. Or if we're running a Node.js application, the index.js file is up and running, and it is responding to 100. This kind of test. So it will do the test. If it is fine, then it will just do decommission 1 pod, and it will just add 1 by 1. So that is one of the deployment strategy. So they call it a strategy. This is called rolling update. So you are doing 1 by 1. But sometime for some application, we want to make sure that all the client is getting same version. In that case, we'll use a strategy called recate. So that will almost do the same thing that we did here, but it will happen automatically. We don't have to do it manually. So that will be something like we have first application, then we have this, then it will deploy the second version, it will swap the traffic to second version, then it will automatically decommission everything. Yeah, so that's about deployment, and deployment can deploy without any downtime when we are using rolling update. But for recate, maybe it will have a few seconds of downtime. And also we can revert these changes. So let's say we deployed the version 2 after, let's say, few testing, or like after user start to use it, we realize that there is a big bug there, and we don't want to keep using version 2. So we can just automatically, not automatically, we can roll it roll the application to version 1 very, very easily. That is a good thing about deployment. And also can control the rollout. In previous animation, we saw that we have 4 pod, and it was like decommissioning, commissioning 1 and decommissioning 1 at a time. But let's say if we have 100 pod, it will take a lot of time. That will be not feasible. In that case, maybe we can say 10%. So it will do 10% at a time, 10 pod at a time. And then all the definition is declarative, so you don't have to tell the deployment how to do things. So we'll just say that we want for 1 replica set with 4 pod, and it will do everything for us. That's all about deployment. So now we will see next thing that is called service. So we can see that we are running a replica set that is running, let's say, backend application with 4 pod. And we previously discussed that each and every pod will have its own IP. So how will we communicate with this backend application? Although we are running 4 different pod, but this is a single application. So we should communicate with it as a single application, not like 4 separate pod. So to solve this problem, Kubernetes have another like a virtual object that's called service. So service is yeah, we are showing the service here, and if we see here, it have a IP address. Also, it have a DNS name. So we can just call Nginx service, and it will resolve to this IP, and it can communicate with this service. And service will act as a uh, work as a load balancer for all the pod. So if we just make the request to Nginx service, it will just forward the traffic to one of the pod. So that way, discovering all the pod that is belongs to that particular backend application will be discoverable easily. Sorry. Yeah. So one good thing about service is it have a single IP address and it never changes until you delete and recreate it. As long as it is up and running, it will have a single IP address. But on top of that, it will also have a DNS name, and we can just, even if we delete and recreate, the DNS name will not change. So even if we recreate, we still can communicate with the service with the same name. And the next thing is fix. Same thing we already discussed, and it is to work as a load balancer for number of pod. And this is the entry point for internal and external client. Yeah. So I would like to answer if anybody have any question about replica set, deployment, and service.
Listener, if you have any question, just let us know in the chat box. আমার মনে হয় সবারই মোটামুটি বিষয়টা ক্লিয়ার। থ্যাঙ্কস আরিফুল, আপনি খুব ভালোভাবেই জিনিসটাকে ই করছেন, এক্সপ্লেনেশন করছেন। তারপর হ্যাঁ, একটা কোশ্চেন পাইছে, হোয়াট ইজ দ্য ডিফারেন্স বিটুইন ELB and service? That means ELB means elastic load balancing or something like that, I think.
Okay, so if I got it right, let me try to discuss that in Bengali, in Bangla. Okay, আমি যদি কোশ্চেনটা ভালোভাবে বুঝে থাকি, so the question is service আর ইলাস্টিক লোড ব্যালেন্সার, AWS ইলাস্টিক লোড ব্যালেন্সার মধ্যে পার্থক্য কি? So ইলাস্টিক লোড ব্যালেন্সার হচ্ছে একটা সার্ভিস।
You can explain in English because whoever asked, Purna asked this question and he doesn't understand Bengali, so I think.
Okay, then we should discuss it in English. So Elastic Load Balancer is a service from AWS. It is a managed service. We can commission a load balancer in VPC, where whenever service is like a internal thing of Kubernetes. So we can provision a service inside a Kubernetes cluster, and it can load balance between all the pod that is running into Kubernetes cluster. Whenever ELB can load balance between anything, like a number of IP address that have to be private IP, you cannot load balance between public IP. As far as I remember, you can load balance between EC2 instance or anything. So in real world, what happens? So if we are like if we deploy the application into Kubernetes, and let's say it's a front-end application, so customer need to get into this application. We'll create a service inside Kubernetes, and we will also uh, using ingress controller. Will come to that just just after 2-3 slide. So we'll commission another Kubernetes object that is called ingress controller that will provision a ELB for us, or we can do it manually, doesn't matter. So we'll have the ELB that whatever provision automatically or whatever we created it ourselves. So
So, in a sense, you are saying that service is a micro level load balancing. It's not like fast like ELB, elastic load balancing, where it can balance to multiple EC2 instances or multiple machines. But here, service only load balance to a specific type of application or a specific type of application pods to say it specifically. Am I right?
uh, there's a little bit difference if we go into details of service. So service is a virtual load balancer. It's not a real load balancer. So
Okay.
if you look into ELB, all the traffic will go to ELB, and ELB will decide where the traffic should go. But in reality, service doesn't exist. So what will happen? We'll have a service. It will have an IP address. It will have a DNS name. Let's say we are using DNS name. So whenever a client will try to communicate with this service, it will use the DNS name, and service will just return one of the pod IP address. So
Oh,
client
it
will
will.
directly communicate with pod,
Mhm.
but to know about this pod IP address, it can just come to service. It can communicate with service, and service will provide it that.
Okay, so
And
it doesn't matter if any of the pod is kind of overwhelmed or too many requests. It will just select randomly any of the pods to service the request.
no, we can define how to like distribute like how to load
Okay.
balance the traffic as well. In service is a virtual load balancer, but it's a load balancer, but it's not control. It's not handling the traffic. That's the point. All the traffic between two pod will just have direct communication with each other. So all the pod running into cluster,
Mm-hmm.
whatever they're running into same node or different node,
Mm-hmm.
they will communicate with each other directly. There will be no like middleman whenever
Oh,
they're
okay.
communicating.
Okay.
But
Okay.
as we saw that there is like 4 pod running, maybe
Mm-hmm.
it can 10, 20 or 100.
Mm-hmm.
So it will be very, very hard to like provide the IP. Also the IP can change anytime.
Mm.
To provide a like a uh, permanent name, we
Mm-hmm.
are using service, but
Okay.
service will not handle the traffic.
Okay. So I think Purna got his answer. So please continue.
Yeah, sure. Okay, just a little bit. Okay, so we already look into for basic building block of Kubernetes. Next thing we look into is called Helm. That is a another cloud native foundation project that work as a package manager for Kubernetes. So what is the package manager? I think we already used like apt or yum if we are using Linux, or we use Linux for anything like configuring server or etc. So Helm is like apt or yum for Kubernetes. So it will resolve all the dependency to run a application run an application and it will resolve everything, and also it will automatically get all the resource like we saw pod deployment service. All those things will be gated by Helm without us writing anything every time we want to get this application. And on top of that, Helm also provide like a meta language, so we can put some condition in Kubernetes manifest file. The file we saw earlier for pod, that's called Kubernetes manifest file. So we also can add some logic there, like some condition, some loop, like adding some uh, programmability so that we can make the decision inside that. So, so it will help us like define the application, install it, update it, uninstall it, and maintaining the full application lifecycle. If I want to put it into single sentence, so it will help us managing the full application lifecycle using Kubernetes. We'll also look into one short demo with Helm later in our session. And yeah, now we came into ingress controllers. So uh, we already discussed a little bit when Purna asked about ELP and service, but we'll discuss a little more here, and we can see a picture. I think that will make it easier for us to understand. So we can see that we are running uh, different pods for, let's say this is application 1, this is application 2, and we have service 1 and service 2. Those are Kubernetes thing. And on top of that, this is also a Kubernetes thing. So that is also like a virtual uh, object in Kubernetes that's called ingress, and it make the decision like where to send the traffic. So that's work little bit as a load balancer, but not a load balancer. That's work as a router. If you look into networking world, so that's work like a router, but we're not going to that. And here comes our ELB, or it can be anything. It can be EC2 instance, physical machine, or AC epoxy, or anything. So all the requests will come to this point. Let's say it is a ELB, application load balancer, and then application load balancer will forward the traffic to all the Kubernetes node at a specific port where this ingress is running. Then it will distribute. Actually, the process is like very, very complex, but let's simplify it. We'll have a load balancer, and the load balancer will redirect the traffic to Kubernetes, and Kubernetes, inside Kubernetes, there is something called ingress, and ingress will decide it which service or which pod or it should send that traffic to, and then it will forward it there. So this is the way to let internet traffic or outside world traffic into Kubernetes, because Kubernetes doesn't have like a direct connection to outside world. And this is the gateway to outside world. Any question on this two topic?
Listener, if you have any question, just let us know. I think it's fine. You can continue.
Okay. So you can continue. Now this is demo time. We'll get a Kubernetes cluster using kind, and we'll also get pod, replica set, deployment, and service, and we'll see how things are got created and how we'll also explore all those things that we discussed. So for that, we need to go to our VM. So this is our VM. Demo. So need some This one bit. So need this space. So let's move it to 8. Yeah, what happened to this? Okay. Okay, we'll open a terminal and we'll install all those tools that we're gonna use and also get a cluster. Then we'll get pod and then other things. So first thing we'll install is called kubectl. This is a command line tool for Kubernetes. So it's a Kubernetes client that developed by Kubernetes team to communicate with Kubernetes cluster. So first we'll download this using curl. Then we'll set a execution permission on top of that and demo. And then we'll move it to user local bin so that we can execute it without defining the full path. So I guess everybody at least understand what we are doing in this three line. If it's not clear, we can discuss little more.
No, that's fine. I think it's
Yeah.
quite simple. If anyone using Linux, they should be familiar with it.
Yeah, so let's see. So now kubectl is available to us. The second thing we'll install is kind. This is Kubernetes in Docker. So we'll run a Kubernetes cluster in Docker container. This is the easiest way to run a local cluster. So you don't need anything. You just need a up and running Docker. And then you can install kind and you can get cluster, and cluster is like very, very flexible. You can get multiple cluster with very, very minimum resource, and you can just destroy it, recreate it easily. So that is the best way to like mess up thing and going back to the original state easily. So sorry, copied the wrong thing. Let me minimize this. Okay,
So,
install
can you
it.
just tell us a little bit about kind, why we should install that?
Yeah, kind is, as I mentioned, Kubernetes in Docker. So it will uh, get a Kubernetes cluster inside a Docker container. When it will be just a very, very easy thing to get so that we can play in that particular cluster. So there's nothing very special about kind. There's other platform to get local cluster like Minikube, and also you can like get multiple virtual host in virtual box and just set up there. But you have to, in that case, you have to set up everything yourself. With this, everything will be come out of box very, very easily with single command. We'll saw that in few moments. And that's it. There's nothing special, but we already have this link here. So if you are interested to know more about kind, you can go there and explore. They already have very good video there. Also have very comprehensive documentation. So for us, we are just using it to get a cluster. But whatever we are using, kind or any other platform, doesn't matter. Also nowadays there is a few online platform where you can go and just do a single click and you will get a Kubernetes cluster online without like even using a local machine. That also can be used to run. So kind is up and running.
Ariful, can you just share the link with us? Someone is
For
asking for the
creating.
link. I think that
This
notion.
link. This link is already provided here. So this link is already provided here. So you can go there and can see everything that we are using.
That's great. I think that person is just want to explore now. So if you can just
in that case,
provide
I can send it into
a chat box, that chat box to everyone.
Yeah. Okay. Okay. Let me send it in chat box. So you can find the chat. Yeah, got it. Okay, let me move it to the window. Yeah. Sorry, I got the wrong link. Yeah, I sent it. You can explore it if you want. Okay. So next thing we'll set up is called lens. This is a ID for Kubernetes that is like a easier version for beginner, easier version of kubectl for beginner. We'll also look a little bit about that, but we'll use snap for installing it. So we have to install snap first, and snap is installed. Snap is a packet manager from Ubuntu that make installing thing even easier than apt, especially complex application. So let's install lens. Okay. So all the tools is up and running. So we can run lens now. Let's see lens. Okay. Now we'll get so this lens, but right now we don't have any cluster, so we cannot do anything here. So first we have to get a cluster. So for getting cluster, the command is very simple: kind get cluster. We can give a name, or we can even just ignore the name. In that case, it will get a cluster name kind -kind. So we are using Cloud Pro because all of us is Cloud Pro. And it will take like 1.5 minutes, I guess, 1.5 to 2 minutes. Consider how much resource you have, like how much CPU and RAM you have. So you have to wait a little bit. We can explore some other things during this time. So we'll get a pod first, then we'll get a replica set, then we'll get a deployment, and at the end we'll get a service. So if we look into the pod definition, it's very simple. It's mainly these two lines. We have to give a name for the pod, and also you have to provide an image. Then this is we are using Docker here, so this is a Docker image, and you can provide a Docker Hub image or your image from your private repository as well. So demo, yeah. So I already created all the file here to save a little bit time. We don't want to
Can
copy
you
paste
just explain about lens a little bit? There is a question. Someone is asking for what is lens.
Yeah, we'll look into lens in a little while when we'll have some pod.
Okay, got it.
So we'll see how lens can help us as a beginner. But most of the professional users, they normally don't use lens. They normally use kubectl because that's more powerful. That required you to learn little more. But if you get familiar with kubectl, it's really hard to stop using kubectl and move to lens. Okay, we forgot one thing, that is to enable autocomplete for Kubernetes. That will be very, very helpful for us. Okay, so autocomplete. So now if we type kubectl, we can see that whatever is available for kubectl as a sub command and sub command. So let's try to get a pod. So we have this pod definition that is for getting an Nginx pod. So vim, we want to see what it's doing. So this is we ask it to get a Nginx pod that will have only one container, and it will run a Nginx server of version 1.19. So let's see how we can get a pod using this definition file. So we'll use kubectl, and we'll use a command, kubectl command called apply. Then we'll supply a file with -f flag, and we'll supply this file for Nginx, and it will get it, and we can see it using kubectl get po. So we can see that it's getting the pod for us. So right now it is getting the container for us. I guess it is already got gated. So it's got gated and running. And now as we already have a cluster, we can add that cluster here in lens. So we can see that we only have one cluster right now. If we have multiple cluster configure here, then we can select one that we want to work with, but we have only one. So let's select that, and let's add the cluster. Yeah, so this is lens. If we go to workload and pod, we can see that one pod is running here. And if we want, we can directly connect to the pod from here. So if we do ls, we can see that this is a Linux server, like Linux container, and it's running everything. And it is currently running a Nginx pod. So maybe we also want to see actually the web page that is returning. For that, we can use kubectl.
So yeah, Lens is kind of user interface. Instead of using the kubectl, we can get all kind of organized in the user interface, and from there we can browse and check all about the different pods and replica set, everything. Am I right?
Yeah, so both Lens and kubectl is a Kubernetes client. Both are client. There is
Okay.
nothing special about kubectl or something. Both are client. One is like command line one is GUI.
Yeah,
And
just
GUI
like
one have
yeah,
less feature, that's it.
we can compare it to AWS command line and then AWS
Yeah.
user interface. Got
Yes,
it.
right.
I
So we are
think it's
using
clear to everyone. Purna, I hope it's clear to you.
yeah. Is anybody have any question about Lens or anything else? Because
Yeah,
we'll see
yeah.
little more
Now it's clear. I got.
during our demo, both Lens and kubectl. So next thing we are trying to do is like using port forwarding, so that we can see that we are getting a Nginx space from our pod. So kubectl port forward Nginx pod, and we want to mount it into port 8081 and 80. So now it's got binded on port 8081. So if we go here and type localhost port 8081. Sorry, yeah, there's a typo here. call host. Yeah, so you can see Nginx is up and running. And to be sure 100% that this is the pod, we just terminated the pipe, the tunnel, and if we explore, refresh it, it's gone. Then just do it again, and it's gone. And yeah, but still we are not 100% sure that this is the pod. So one bad thing about pod is get PO. Sorry, I normally type K just. Yeah. So one bad thing about pod is if it got deleted, it is gone. It will not come back again. So let's delete the pod. kubectl nginx sorry, delete delete pod this pod. Oh, sorry, we don't have autocomplete here. I forgot that. Okay, so it got deleted. If we come here, our tunnel is still up and running. But if we come here and refresh it, we can see that it is not responding anymore. Or you can open another tab and see it's not responding anymore because our pod is gone, although this tunnel is up and running. And we are getting some error now because it cannot respond. So to solve this problem, that if the pod is gone, everything is gone, we'll get a replica set instead of pod. So we have a replica set file in replica set. So we can see that we have the same thing, image and name. The name is different, but the image is still Nginx. In this case, it will use the latest image. And we have some more configuration, but we defined that we want 3 replica. So it will start 3 pod instead of 1 pod. Previously, when we created it created only 1 pod. And the kind is, so every definition, Kubernetes definition file or manifest file will have these 2 things. One is API version and second thing is kind. So for replica, the kind is replica set. For pod, it was pod. So let's get using this kubectl sorry, apply -f replica set. It's got created. Now we can see also with one more flag. So it's now running. It's running 4. It was have 3. Okay. It looks little bit okay. Okay, maybe the replica was 4, not 3. We just you can see again. Yeah. Sorry, it's get 3. That was like a status we saw at the beginning. So it's running 3 pod now. You can see here. And if we now delete 1 pod, like before, kubectl delete pod, let's say, yeah, previously if we see the name, that was Kubernetes pod, but we can see that now there is a random number at the end. That is because it is managed by a replica set and it have to create like multiple one. So it just put a random number at the end of the name so that it can get multiple one without any conflict, because the name must be unique. We cannot use the same name multiple times. So we deleted 1 pod. And if we come here and see the double flag, so we can see that the pod with 90, that doesn't exist anymore. and in place of that, it's created a new pod.
So it will automatically create if any pod is deleted, it will
Yeah,
just be replaced. Got it.
yeah, that's true. But as we mentioned that what if the replica set got deleted? So we can see the replica set kubectl get rs. So this is our replica set. Let's delete this replica set. Kubectl delete replica set. That's short for rs. This one. So it got deleted. Now if we look into this, it's getting deleted now, and it's gone. To make sure that even at this replication level, we will always maintain the thing, we'll use deployment. So let's recreate this and then get the deployment, because we'll need this again. And
I
let's
hope
get a,
the listener can
oh,
make the
sorry.
connection. Yeah, sorry to interrupt. I hope the listener is able to make the connection why we are using the replica set. What was the problem? So if you have any question, just let us know. We can clarify that.
Okay.
Please continue.
Yeah. So we can also look same thing into lens. So we have a replica set, then we don't have any deployment yet, but we have 3 node, and we can 3 pod, and we can just
There is a
like log
question.
into one.
Uh,
Yeah.
Pod deleted, so we want to recreate it. I think it's automatically recreated by the replica set, isn't it?
Yeah, if we create a pod directly, it will
Yeah.
not got
Okay.
recreated if it got deleted.
Okay. It will
That's
be
why we are
gone.
using replica set. If it is part of a replica set, then it will got recreated automatically if it got deleted.
Okay. I think Purna, you got your answer. If you need clarification, just let us know.
Yeah. So whatever we saw in using kubectl, we can see the same thing here. And it's just a little bit easier for anybody who's new to Kubernetes, because it's a GUI. But there's no difference or special thing about either of this. One is GUI, one is command line. Yeah, now we want to get a deployment. Now we get a deployment.
Okay.
And if
Another
we saw,
question, Ariful. It's related to that pod deletion. So replica set is the solution provided if the pod is deleted or else, something like that.
yeah, this is the solution to make sure that a specified number of pod is up and running all the time.
Okay. I think Purna got it.
Yeah. So now we can see that instead of 2 pod, we have 5 pod or 2 form deployment. We define the name accordingly. But if we saw 2 new pod that is created by deployment that have even longer name. So there is this random string before this random thing that we saw happened with the replica set. So this is the idea of replica set. So it's getting a replica set, deployment is getting replica set, and this replica set is getting pod for us. So it have double
Okay.
identity now. And we can see the same thing in lens. So now we have a deployment, and we can see the all the information about deployment. If we go to pod, we have 5 now. Same way you can just log into one of the container main it have only one, so we don't need to define like which container we want to log into. But if we have multiple one, we also have to define like which container we can log into. If we have multiple one, we can log into any of the container individually.
Okay, so deployments is kind of maintaining multiple replica sets.
Yeah.
Different kind of replica set.
Yeah. We can see that easily, like we define about this rolling update. Let's see how this is happening. So let's enable the observe bus flag here. So this is our current state of our cluster. We are running 5 pod. And now we'll edit this deployment file using Vim. And right now it's running Nginx 1.8. That is very old version, and we don't want to run old version. So we updated it to Nginx 1.19. And now, okay, indentation is perfect. We can save this, and then we can again apply this one, and then it get configured. So previously it was created and it's got configured now. If we come here, that we can see that there's a lot of activity happening in our cluster after doing that. So it's the old replica set was 6C. So 6C is getting terminated, and it's getting another replica set in that place. That is 5.8, and it's pending. Now it's running, and everything is done. So if we come here and get pod, so you can see that our old 2 pod is got replaced with new pods. And if we come to lens, if we go to replica set, we can see that there's 3 replica sets right now. One is created by us and 2 is created by that deployment.
That's really cool. But will be there any downtime when we are doing?
Yeah, if we are using rolling update, the animation we saw, there will be no downtime, given that you have multiple pod, at least 2 pod. If you have 1 pod, even with rolling update, it will have little bit downtime. But with multiple one, it will not have any downtime.
Got it.
So all good. We have this thing, but now we can see that we have 5 pod. Those actually having the same label. So there is a thing called label. We will use that to get our service. So label is app equal nginx for all pod. So whatever is coming from the deployment, it have label of application equal nginx, or whatever is coming from the replica set, same label. And now we will use this label to get a service, and that service will load balance between all these 5 pod. So we use this label. We can use multiple label to this work like a filter. So we can just filter and define that which pod this service should include to load balance. So let's look at service definition or service manifest file. Vim. Okay, look like we don't have service definition here, but we can get it easily. Vim service.yml. So yeah, this is the service definition, and here is the selector, and we define that app equal engine. So it will only select all the pod that have a label app and the values nginx, and that's true for all our 5 pod. So let's get the service. So we can see kubectl get service, And we have only one service that is created by Kubernetes itself. We can see it got created 21 minutes ago. And now we'll get our own service. kubectl apply -f service.yml. And if we saw get service, now we have two service. And we can also see the service here, I guess. Okay, networking, it is under networking services. So we can see two service into Kubernetes. So Kubernetes, let's divide that thing into, I guess, 4 part: configuration and workload and network. So we mainly working with workload and networking. There's more thing into Kubernetes. You can see a lot more thing. And also there's something called storage, and one of the important building block we just ignored, that is called namespace. So we are currently working in default namespace. So you can create namespace that work like a partition in your Kubernetes cluster. That also will be helpful for learning more about Kubernetes. But just for now, we are working on default namespace that is come out of the box with new Kubernetes, and we are doing everything in default namespace.
So, Ariful, what's the difference between manually creating the service or created by Kubernetes?
There's no difference. Both are same. One is like this is used for the API server. We discussed at the beginning about API server. Yeah, sorry, this one. This is used by control plane, or to be specific,
master node.
Master node Kube API server, Kube API server. So that's it. But both are same thing. There's no special thing about the one that created by Kubernetes.
Got it. Thanks, Ariful.
Okay, so now we have a load balance service, and we want to see the same thing that we saw. We saw Nginx space at the beginning. We also want to see the Nginx space using service now. So kubectl port forward, and now we're gonna forward a service. The service name is Nginx service, and we'll use the same port number 8180. Sorry. Okay, server. Okay, sorry, we have to use separate, different. Does not have a port 80. Okay, so our service is missing one configuration, so we cannot like stupid pim service. So we have to add one more thing here. Okay, so port. Oh, sorry, our port service running listening on port 8000. So we have to define it on port 8000. That's it, nothing else.
You change the indentation in there. Is it fine?
Yeah, that is fine. It worked. So now we are forwarding port 8080, but you can see that it is got forwarded to port 8081 to 80. That because service is a virtual thing. It just help us resolve the IP address. It doesn't handle the traffic. That's why the traffic is directly going to one of the pod, and also port forwarding is happening to one of the pod. So if we remember, our pod is listening at port 80. So we port forwarded to port 8080, sorry, 8000, but in reality, it's just forwarded to port 80 of one pod. And if we go here, And if we refresh, then we can see the engine space again. So that's everything about demo. Anybody have any question?
Listener, if you have any question, just let us know. আপনাদের কোনো প্রশ্ন থাকলে অবশ্যই চ্যাট বক্সে জানাতে পারেন। Ariful, please continue.
Yeah, okay, that's great.
If there are any question, I just let you know.
Yeah. So let's go back to the slide. So that was the demo to like see how things are working pod, replica set, deployment, and service together. And next thing is like we only learn like very basic about Kubernetes in our session, but Kubernetes, some part of Kubernetes is little bit complex, but most of Kubernetes is very simple, very easy to learn. Kubernetes have is official documentation that have a lot of information in it, but as a beginner, it will be a little bit difficult to explore official documentation. But that's my experience. If you are a beginner, I was a beginner at the 2 years ago learning Kubernetes. I went to like 3 years ago, I was trying to start Kubernetes only with Kubernetes documentation and some other resources, but Kubernetes official documentation was very tough to start with. And then I like learned nothing for 1 year. Then I become very serious that I have to learn Kubernetes. This is very cool. So I decided to get certified and I studied and I use heavily Kubernetes official documentation during this learning process. But at the beginning, it was not the official documentation. So if you are into books, like if you really love books, I will recommend 2 books. One is the Kubernetes book. This is the book I will recommend for any beginner to start learning Kubernetes. It is explains every basic things from the beginning. It is starting with Kubernetes architecture, then what is pod. That's like a very I think Purna is writing something.
Yeah.
Very basic thing, very like it explain everything very easy language. So it's very beginner friendly.
There's
And
a
the second,
question. When we are using -f in our command line, is it meaning by force or something like that?
it's mean file, not force.
It means file. Okay. Yeah. Please continue. Yeah.
Okay, the second book I will recommend, that is my favorite Kubernetes book, but this is for advanced user. So you have to be like little bit proficient to start reading this book. It will not it will explain what is pod, but not for a beginner. If you already know at least little bit about pod, then you will understand their explanation, else it will be get lost here. So I'll recommend to start with Kubernetes, the Kubernetes book if you are into books. And second recommendation, if you like to take some online course or something, in that case, I'll recommend Kubernetes Certified Application Developer to start. This is, I find, one of the very good one. There's a lot more there. Whatever you like, you can use that. But yeah, that is one of the good one you can start with. But most important thing is you have to get a local cluster or online cluster or any cluster. So you should have access to a Kubernetes cluster. We saw that getting a local Kubernetes cluster using kind is very easy. Only one command line and you will get a cluster. So you can continue with that one. And you should spend like minimum 20 hours in cluster itself, getting, destroying, trying out thing, getting error, solving those error, those kind of thing, minimum 20 hour. Or just minimum. It's not like that you'll become expert with 20 hour. You'll to understand things at a basic proficient level, you have to spend minimum 20 hours. That's it. Okay. Sorry. And BA Cloud Pro is also planning. Sorry for the spelling mistake. There is a typo here. Planning to release a Kubernetes course, so can keep eye on BA Cloud Pro website. Maybe we'll release a course in future. And here's the final notes. Understanding the pod, what is a pod, how pod is work, what is a pod is not, how you can or how you should define a pod, what should you put inside a pod, how should you structure pod, those kind of thing. That is very, very important. If you understand pod very clearly, it will become very, very easy for you to learn rest of the thing about Kubernetes. And second point is what we already mentioned, that you should spend minimum 20 hours in a Kubernetes cluster to become proficient with Kubernetes. Second thing is to play in a Kubernetes cluster. You can follow this link. This is from official documentation. They have like a lot of, I guess, 100+ scenario-based tasks that you can just use for your play, like trying out things. Like we only get it like 4 things. Similar way, how to get a pod, how to get a deployment, how to get a service. All those things are like a unit by unit divided there. So you'll never get overwhelmed with the what you need to do, but it's like a bite-sized chunk. Second thing is take any video course, read some good books. That is always important to learning any technology at a very good, with a very good proficiency. Video course is good for studying, but reading book is must to become very, very good with particular technology. Yeah, now question and answer. So if anybody have any other question, we already have like some mini question and answer session, but this will be like a final thing.
Ariful, many thanks. I think it was an excellent presentation and also the hands-on. And everyone who is kind of interested in Kubernetes, at least they got an introduction and the total overview. How can they progress from here? And it was really helpful for them. That's my opinion. I hope everyone will agree with me. আমার সাথে সবাই আপনারা একমত হবেন এই বিষয়ে। আপনাদের কোনো কোশ্চেন থাকলে অবশ্যই চ্যাট বক্সে জানান। আমরা কোশ্চেন আনসার দেওয়ার জন্য কিছুক্ষণ ওয়েট করব অবশ্যই। আর লিসেনারদের জানাতে চাই যে আমাদের এই ওয়েবিনার সম্পর্কে তাদের গুরুত্বপূর্ণ মতামত bacloud@gmail.com ইমেল করে জানাতে পারেন। টেকনোলজি রিলেটেড গুরুত্বপূর্ণ ভিডিও আমাদের ওই ইউটিউব চ্যানেলে আমরা নিয়মিত আপলোড করি। এছাড়া আমাদের আরও পূর্ববর্তী ওয়েবিনারের ভিডিওগুলো আমাদের ইউটিউব চ্যানেলে আপলোড করা আছে। আপনারা যে কোনো সময় সেখানে দেখতে পারেন এবং এই ওয়েবিনারটাও আমরা আপলোড করব খুব দ্রুত। আপনারা সেখানে গিয়ে এই ওয়েবিনারটা আবার দেখতে পারেন, রিভিউ করতে পারেন। এবং আপনাদেরকে অনুরোধ করব আমাদের ইউটিউব চ্যানেলে সাবস্ক্রাইব করার জন্য, যাতে আপনারা এই গুরুত্বপূর্ণ ভিডিওগুলো দেখতে পারেন, আমাদের সাথে নিয়মিত যোগাযোগ রাখতে পারেন এবং আমাদের ফেসবুক বা সোশ্যাল মিডিয়া লিঙ্কডইনে আমাদের সাথে যোগাযোগ রাখার জন্য এবং আপনাদের গুরুত্বপূর্ণ মতামত জানানোর অনুরোধ করব। There's a question. Maybe this being my first class, it would have been more useful if you could show how and what kind of server you launch in AWS cloud for spinning the servers and cluster.
Okay. I think maybe there is a little bit misunderstanding. Purna thought that we are using AWS EC2 to set up the cluster. That is not the case. We are using VirtualBox. We created a VirtualBox. Okay, let me show you what we are using. Then maybe it is more clear to you. Yeah, just one sec. Let me ping my VirtualBox. Yeah. So we are using, can you see it?
Yeah, I
Yeah,
can see it.
we are using a VirtualBox, nothing special. But you can do the same thing in a EC2 instance as well, or like a GCP VirtualBox or Azure VirtualBox or any other places. There's nothing special. We need a virtual machine or like say machine, and we use a VirtualBox for this.
That's great. I think Purna got his answer because you can easily just learn in your virtual box in your machine, and when you are kind of proficient, you wanna try in cloud, you can do it anytime.
Yeah.
আমরা অনুষ্ঠানের শেষ প্রান্তে চলে এসেছি। কারো কোনো কোশ্চেন থাকলে অবশ্যই আমরা কোশ্চেন আনসার দেওয়ার জন্য আরো কিছুক্ষণ ওয়েট করব। Thanks everyone for your time, and it was an excellent presentation on Kubernetes, and I hope everyone was beneficial from this webinar. And আমি পার্সোনালি বলবো আমি নিজেও কিছুটা উপকৃত হয়েছি, and hopefully this is same for everyone. Thanks everyone for your time.
Thanks everyone for joining the session, and I hope you learn more about Kubernetes, and hopefully whatever I try to present that will be helpful for you in Kubernetes journey.
Yeah, and if you guys are interested, just let us know in our social media or in the email or YouTube channel comment that you're interested for more Kubernetes session or much more advanced topics. We can arrange webinar on those topics. So let's conclude this meeting. Thanks everyone.